Alrighty folks, on to Unity we go. So here we have a couple of example characters that I set up, and let me just enable gizmos here and you will all understand in a second. But here we have a bloody effect, here we have this golden type of shine, right? We have this one which is a slimy type of effect. This one is one that I might not teach in this tutorial. We do have a tutorial covering matte caps, so this is just a material capture. So we're going to link the tutorial for matte caps in the description, but everything else we're going to cover here on this tutorial. And additionally, these little shader techniques here, they will be an update to the Piloto Studio VFX pack for mesh effects. So, you know, if you don't want to follow along, and if you also want beautiful particle systems like this one to accompany your mesh effects, stay tuned, because probably on January-ish, we'll have an update to the Piloto Studio asset store. We're going to be adding this shader here as a new added feature. So without further ado, let's go. We're using Amplify, very important. So let's create a new shader here, and we're going to make it Amplify Surface Shader, and we're going to name it Mesh Overlay Effects. That's a very sensible name. Let's open it up. All right, great. So here we are on the Amplify interface. A couple of changes here that I'm going to make is that from surface, I'm going to make it a unlit shader. By the way, if you're using URP or standard, it works just as well. So do not worry about me using the HDRP preset there. That's just because I like HDRP, so I use it. That's all there is to it. So a couple of settings here. I think the default shader behavior should be transparent. This technique works with opaque shaders just as well, but why not use transparent, right? Most of the time you are going to use transparent effects. I'm going to keep fog. I'm going to keep the depth right. I think that's pretty much it for the preliminary changes that we're going to be making here. So what are we going to be doing actually with the shader? Let's think a little bit about how we are actually handling these things, because the way that this works here, in case it's not obvious, is that, let me grab this character here so we can use as an example. So the way that this works, in case it's not obvious, is that we do have a material slot. So if I open my little character here, you're going to notice that we have here materials, and we have the PBR gradient and the overlay material blood. So this overlay material blood is actually this material over here using the shader that we're going to create. And you can see here that it's UV independent. So it doesn't matter what I make here. Like if I make a cylinder, right, with the default Unity material, and I click on the little mesh renderer to add a new material slot, if I put the blood material here, you can see what happens. We just now have the bloody material overlay, and this bloody material overlay is UV independent. This is not using the UVs whatsoever, and this is pretty much the way that things go here. This is the setup. We're actually using the bounding box of the model to drive the UVs. So 99% of the cases, it's going to be a perfect fit. Now, of course, on the cylinder there, we had a little bit of weirdness with the plane, but don't worry. Of course, in some cases, it might look a little bit goofy, but you can adjust the settings on the material so that it doesn't look goofy, right? On this character in particular, you can see that it works really well. And if I grab my sword here, you can see that the sword as well also has the bloody material. Now, something interesting here that you might have realized is that when I select the sword, this guy became a little bit striped, right? Like came a little bit weird. It almost looks like the blood became thinner. And when I click on this guy, it fixes itself. The blood texture changes. So the reason why this is happening, it's because this shader actually needs a little bit of help from a script to properly work. So here we have this local bounds setter. As I said before, we are using the local bounds to drive this behavior. So the very first thing that we must do here is to find a way to set the local bounds from the CPU information and bring that information over to the shader. So we're essentially taking data from the CPU and porting it over to the GPU with the help of a little bit of a script. Let's do that. It's actually incredibly simple. So the information that we're going to have to fetch here is going to be a vector3. So let's make this vector3 a property, meaning that we're going to be able to change it on a per material basis. And we're going to call this one local bounds minimum. And as the savvier among you might have realized, we're going to duplicate it, and we're going to have, if we have a minimum, of course, we're going to have a maximum as well. Perfect. So now we have the local bounds minimum and maximum values, and these are going to be set by our script. So we need to turn these things into a UV set of UV coordinates that we can manipulate. Because let's create a texture here, and let me just get a random noise texture here. So let's get this caustic noise, right? And if I just plug this into the color, right? I'm also going to plug this into the emission. And why not? Let me also plug it into the alpha. So if I save this and we create a material out of it and I try to apply it, you're going to realize that it's going to use the UV sets. So if I right click, create material, and I go over to my little assassin guy and I put this here, you can barely even see the textures, right? You can kind of see it over there a little bit, just a tiny bit. And the reason why you can barely see it is because, well, simply put, the UV channels for this character are very tight and very tiny. If this uses the UV to sample their position, it's just not going to work here. So you can kind of see what that looks like a little bit. So in order to fix that, we need to create UVs from the local bounds. So let's begin on the logic here. I'm not going to make the full 9 yards because I want to show you what those UV actually look like. So what we're going to do is that we're going to take the rolled position, and what we're going to do is that we're going to turn the rolled position into objects. We're going to do a transform position here. Great. And we're going to set it from rolled, it's wrong here, to object. So we're essentially going to flip those around. The default values are going to be flipped. So now we have the transform object position for the character, and we're going to subtract that. My video, I have a video on locked UVs for the Unreal Engine. There I explain a little bit better how the relationship between, when you subtract things from positions on a Cartesian plane, you're also moving them. So what we're doing here is that we're moving the position of our character by the local bounds minimum, and we're going to subtract again. So let me grab another subtract node, and we're going to subtract the local bounds minimum by the local bounds maximum. So now we have the difference between those two, which we'll use to divide here. So when we do this, we actually get a set of somewhat usable UV coordinates. Now, they're not entirely usable quite yet because these are vector 3s and we want vector 2s to drive the direction of our UVs. So what we can do here is that we can pick and choose different ASICs of this vector 3 and turn them into vector 2 UV sets. What I'm going to do here is that we're going to split, and when you split, you can actually manipulate the X, the Y, and the Z individually. That's the beauty of split. As I said, we only care about 2 of those. So what we're going to do as well is that we're going to make an append, and here are those little 3 dots. We're going to click it and select vector 2. So now we have X and Y. So now we're going to put the X over here, and we're going to put, you guessed it, the Y over here. So now this is one UV set. But we still got the Z there, and that is actually useful. For example, you can put the Y on the X and the Z on the Y, and that's going to flip the direction of the UV set. And you can also do a Z on the X and an X on the Y, and now you have 3 different UV sets from the local bounds. How can we pick and choose between these 3, right? Sometimes I want to have regular UV, sometimes I want to flip it by 90 degrees, for example. So we're going to make a static switch. So static switches are a little bit complicated, but the best way to describe it is that they're kind of like if statements inside of your code. So what we're going to make here is that we're going to create shader feature, and we're going to make it a keyword enumerator. On the name, we can call it, I don't know, let's call it UV direction. And on the amount, we're going to make 3 members. So we're going to have 3 items to choose from. And those are going to be X, Y, and Z. Great. So now we can keep all the other settings as they are, actually. And we're going to plug this first one on the X, the second one on the Y, this last one on the Z. Perfect. we already have, this is a working set of UVs. We're going to make some further modifications to it, but for now, let's just drag and drop this here and see what that looks like. And you'll quickly realize that we're going to have a bug, but don't worry, I know how to fix it. Let's save it here. And if I go into Unity, you're going to notice that now nothing is showing up. But why is that? Why is nothing showing up? Well, essentially, our bounding box is set to be 0, 0, 0. That's pretty much it. That's the reason. So you can see here, local bounds minimum 0, 0, 0, local bounds maximum 0, 0, 0. So let's try and make the maximum like 10, 10, 10. Does that change anything? Nope. Let me try here. I don't know which numbers would do something to it. Point is, this is not working. But don't worry, because local bounds is actually something that the Unity API has exposed for us. So all we really got to do is make a script that reads the local bounds from the 3D model and shoots it over to our shader. So let's create a new script and we're going to take a look on how to do that. So we're going to call this, I don't know, local bounds Thatcher, maybe? Something like that. The name doesn't matter, folks. You can choose whatever name you want. All right, folks. So here we are. So what we're going to do here is that we're going to create a couple of methods here for us to work with, because we have a little bit of a problem to solve, and that is we want to send over the local bounds minimum and maximum, but we want to do it on editor so that we can see what we're doing, but also in game. But when we're playing in game, we don't want to change the actual material asset. We want to change the material instance, because when you play a game on Unity, you're not using the materials straight up. You're actually using a copied version of the material that was created in runtime just for that instance of play. So when you modify it, you're not actually modifying the asset. You're just modifying that instance that was generated in runtime. And your asset, when you replay the game, it's going to have the settings, the default settings from scratch. But we also want to see our work as we work through it on the engine, right? The workaround that I've found for this is to do a private void on draw gizmos selected. And essentially here we do the preview logic on the actual material asset, right? Meanwhile, here on the start, we do the logic and apply it to the material instance, okay? So this is very important because otherwise, this is the reason why when I showed you the example here, let me just reload, a little bit annoying, but you know, this is the reason why here, if I have these little characters and I put the overlay blood on my little guy here, you can see that if I select the sword, this changes because I'm not modifying the instance of the material, I'm modifying the actual asset, and these both use the same asset. But if I were to play the game, however, if I were to hit play, then I would not be modifying the asset, I would be modifying the actual material instances, and both of them would look correct simultaneously. So let's go. So what we want to do here on the start, first let's create the only variable we'll need, which is a public shader. So it's going to be our shader reference, because we only want to apply this to materials that use this shader that we specify. So what we're going to do here, we're going to make a reference for our renderer, and we're going to get the component renderer. I'm going to name it just R though. I like naming just R. Great. Now we have a reference for our renderer. What we want to do, and this is the actual play behavior, right? So for each material inside, and the name of the material is going to be mat, inside our dot materials. So the renderer holds a reference to every single material inside of an array. So we're essentially sampling whatever materials are inside of this array. What we're going to do is that we're going to check if this material dot shader, so the shader that it's using, is the same as the shader reference, because we only want to apply our logic to the shaders, to this shader here. here that we're going to specify on the editor. In case that's true, then we're going to do a material dot set vector, and we're going to need the name of our vector, right, which is going to be the local bounds minimum and maximum. How do I know the name of my vector, Leo? I don't know the name of this vector. Well, let me show you. So if we go here on True Unity, we can open up the shader that we created, open it up really quickly, and if I get it over here, we have this local bounds minimum and local bounds maximum. So we have the name on the top, and then we have grayed out a little bit the property name. So there's this little lock. So what we can do is that we can unlock it, copy it, right? So this is the minimum. So we can go over here. So we can set this local bounds minimum. And I know that the other one is the same, but with maximum. So if I go over here, I unlock it, I get it. You can see here that it's just local bounds maximum, right? So you can get it that way. So we're going to set this vector local bounds minimum. And what is the value that we want? Well, we want to get our renderer by pressing R, right? And we're going to get a property called local bounds. And if I go local bounds dot min, this is going to return the minimum values, right? So we want to do the same. So we want to do material set vector, but instead of local bounds minimum, now we want local bounds maximum, or whatever you named your variable, comma r dot local bounds dot max. Perfect. So this is literally it. On draw gizmo selected is not going to work because we didn't put anything in here, but it's pretty much the same logic as this. So we can just copy this over and put it here. However, we do want to change just one thing, and that is here we're changing the material instance. So we are doing the logic inside of r.materials. Here we want to change the actual material asset. So instead of doing our materials, we're going to do r.shared materials. Oops. Shared materials with an S. Now this is just going to work. One last thing though, this method here on draw gizmo selected, it runs on the editor. So we need to make sure that this script is always executing. So we're going to do execute always, this little tag on top of everything. We're going to put here execute always. All right, so now if we save this up, let's try it out. So here we have my little assassin clown. Let's get the material that we had created and put it over here. Now, what I'm going to do is that with the skinned mesh renderer game object, it's not the parent object, we need to have the skinned mesh renderer component. It doesn't need to be a skinned mesh renderer, but it does need to be a renderer component. So it can be any types of renderer. With this little guy selected, we're going to drag and drop our local bounds fetcher. And on the shader reference, we're going to put our actual shader. So now you can see that we have our texture being applied independent of the UV channel. Isn't that something? Isn't that something? So this means that this is working. This is just straight up working, lads. Now, of course, this shader is very bare bones right now, and you can see here on the local bounds minimum and maximum, you can see here that the values have been populated. Now, if this doesn't work for you, it might be because you have gizmos disabled. Remember that here, we're doing this logic on gizmos selected on this method here. So if you don't have gizmos enabled and you can toggle them on and off with this little button here, that method is never going to be called because, well, that method is only called if this is enabled. So you gotta have these little things enabled here for that to work. You can put that in other methods that, you can make that into a button, you can do whatever you want, but I would say that on draw gizmo selected is the most natural method because, you're going to click on your model and it's just going to fix itself, when you click on it. I think that's a very elegant solution. So let's improve this shader a little bit because right now it's very bare bones. It has very few features. So let's improve things a little. But the hard part is over though. Now we're just going to make some traditional shader shenanigans here. So the very first W that we can get here is that we can add some features for customization of our shaders. So all of this is our UVs. That's all this is. This is just UV. What you can do over here is that you can drag our UVs out and you can make any type of operation that you would do with regular UVs. So for example, let's multiply it and let's make a new vector 2 and we're going to call this tiling. Let's just call it tiling and we're going to make a default value of 1 and 1. Great. True value of 1 and 1 as well. And we're going to multiply it by each other. Now, if I put this here and I save it, now we have a controller for the tiling of our texture. So if I go over here, I go down here, I have this tiling. If I make it 4 and 4, you can see that our texture is now tiling 4 times. So now we have that control. Let me also change this texture here because I think this texture is not particularly interesting. All right, next thing we can do is that we can add panning to this. So let's right click, make a panner. We are going to put the result of our multiplication into the UV. We're going to make a new vector too, and we're going to call this one panning speed. Whoops, not panning seed, panning speed. So we're going to put this here over at the speed, and we're going to plug this into the UVs. And before we go any further, I'm also going to press 5 and click, and that creates a color node. We're going to make it into a property, and we're going to call this just color. And the default color is going to be white. And very important, folks, over here on attributes, you have this little drop down called HDR. Just click on it. And we're going to multiply this by this. Great. So now what we can do is that we can put this into the color. We can put this into the emission. And for the alpha channel, one small idea that we can do here is that we can also make a float called intensity, or we can use the alpha of the color now that I think about it, but I think it's cleaner having an actual float value personally. And we can multiply this by the RGB by the alpha. So in case the texture doesn't have an alpha channel, we have something to fall back on. And then we put that into the alpha. Now if I save, these are quite a few changes that we made here, but now you're going to realize that this shader is becoming very, very powerful. So let me get my little character here, and you can see that we have an intensity slider, so I can make it fade in and out. We have a color, so I can, change the color. So this is kind of a blue electricity thing. So let's make it pop a little. All right. We also have panning speed, so I can make this thing move. And finally, let's not forget, remember this fella that we made, the static switch? We can change the direction of our UV, and in movement, it's a lot easier to see. Right now it's X. If I put it on Y, you can see how it changes here. I can put it into Z, and you can take a look here at how that changes. So you can kind of manipulate the direction of the UV through that. As one last thing, one last bit of improvement is that you might have realized that we have this local bounds minimum and maximum just taking up space here. The reality is we'll never use that. Guess what? We can just hide it. We still have to make it a property and make it exposed, but you can click here on the attributes and you can click on hide on inspector, and this won't affect our script, but it will make it so it's a little bit cleaner to interface, because now you don't have useless things taking up space. And here we go, folks. This is how you make this incredible material. You can add other features to it. You can add something like Fresnel. You can add, a number of things to it. And as you can see here, it just works really, really well. Just trying out other noises here for us to take a look. You can change the color, of course. You can, make any changes you want. And yeah, thank you so much for watching. And yeah, goodbye.